Multiple regression has several assumptions. In this lecture, I shall discuss two tests, linearity and multicollinearity. To get my file, which is in D drive, I will use the command use. My file name is US crime data. You will notice that on right hand side I have variables, and I have several variables. The data relates to states of USA, and then each state has been given an ID as well. I will assume that murder is my dependent variable, and then independent variables include violent, urban, white, high school, poverty. I shall discuss two commands for testing linearity. The first test plots residuals of regression against each independent variable. Three steps are involved. First, we need to run a regression command. REG or regression, you can write full form, followed by dependent variable and then independent variables. Now I get the regression output here. The next step is to predict residuals. The command is predict, and I will give name R for residuals. You can give any other name. I can write full residuals here or RESID. You will see that on the right hand side one new variable has been added, and if you go to data editor you will find this variable R here. The next step is to create graphs of residuals with each of independent variables. Now the command for doing so is simple. It's a scatter followed by R and then the name of the independent variable. In this case violent, you find that the graph shows that perhaps there is non-linearity between violent and murder. Similarly, you can test linearity of another independent variable, and let me say urban, and once again you find that the data does not disclose linearity, it displays non-linearity, and this is extreme value. It's an outlier perhaps. So again, we do not find this assumption of linearity in case of another independent variable, which is urban here. Similarly, if you run this command for, let's say, white population, and you get again an idea of the distribution of residuals against the variable white, and once again this does not seem to be a linear relationship. You can do the same thing for other variables. There is a second command to test linearity in multiple regression, and this command is called ACPR plot. Then you have to write independent variable after that command, and after comma there are two more commands to be added, low s and lsopts, then within parenthesis b width, your parenthesis, then one more parenthesis, and then you add these brackets. Now the command lowest lsopts b width 1 will provide lowest smoothing with a bandwidth of 1. Now when we hit enter, we get a graph. This graph very clearly shows that the relationship between residuals, which are augmented component, plus residuals, and violent, the independent variable, there is no linearity. There is non-linearity here. You can similarly run this command for other independent variables. Now let me use another one, and this time if I use, let's say, white, and then again I enter, and here it's very clear that the relationship is non-linear. You can perform this command for other independent variables. Next test is multicollinearity. Multicollinearity arises when independent variables are significantly correlated. This distorts coefficients. We will use two commands to test for collinearity. One command is VIF, which stands for variance inflation factor. Before running this command, we need to run regression, but since we have already done that, we can use it, and if I hit enter, I get the VIF measures. Here is VIF value. Now, the general rule is that if VIF value is more than 10, then there is some problem and you need to investigate this. The second command is colon, but it has to follow by independent variables. You don't need to run your regression before using this command. This command will give you several measures. And again, you see that VIF factor is also given, and then you have conditional index, tolerance, and many other. Now, once again, you find that your VIF value is less than 10.